Example 9, we're going to find the component form of a vector. Find the component form of the vector that represents the velocity of an airplane descending at a speed of 150 miles per hour at an angle of 20 degrees below the horizontal as shown. So we're given a couple of things. So we're given the magnitude. So they gave us this here. And so that's the magnitude of V equals 150 miles. Then we need to figure out theta, and so it says 20 degrees, and actually the answer is here, but it's 20 degrees past the horizontal, and so for the direction angle, we know that it's 180 plus 20, so therefore theta is 200 degrees. Okay, so this is the information that it's going to give you in the homework as well. I believe it's number 67. I want you to find the component form, and so it's going to give you the magnitude and the angle, and so you'll do the similar things to those problems. It's just not application problems, but just so you're aware. Okay, let's continue with this problem. So remember earlier that I gave you the formula here at the beginning. V equals the magnitude of cosine theta of I plus the magnitude of cosine of theta j. We're going to use that lots in this section. So we can rewrite this. The vector equals the magnitude of V times cosine of theta, and then I plus the magnitude of V sine of theta j. So let's plug in what we know. So the magnitude of V we know is 150 miles. So 150 times cosine, and our angle is 200 degrees, and then I plus 150 again times sine of 200 degrees times j. So then we can simplify this. If you plug it into your calculator, you will find 150, and this is negative 0.9397I, and then plus 150 times negative 0.3420J, and then you simplify it further, so multiply it out. You get negative 140.96I plus 150, or sorry, minus 51.30J. And then, so you just write it in component form. So remember, all that is you just take out the I and the J and write it like this, 140.96 and negative 51.30. Now we could check. So just remember how we can do a check. So let's just do that real quick. The magnitude of V, that should be 150. And so this is, we want to see if it equals 150. Is that true? So this is you plug it in, negative 140.96 squared, and then plus negative 51.30 squared. And if you plug it in your calculator, that is approximately 150. So that is correct, right? They gave us the magnitude, and we want to make sure that is true. But here's the answer. So try this example here. Find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle 15 degrees below the horizontal. And then it actually gives us theta for us. Theta is 195 degrees. So 180 plus 15 is 195 degrees. So try this out. All right, if you try this out, velocity, the magnitude of V is 100, so you plug that in. 100 times the cosine of 195 degrees I times I, plus 100 sine of 95 degrees J. So that will be negative 96.59 I minus 25.88 J, and so then this is what it is in component form. Then you could always do a check, make sure that the magnitude does match, and it is, if you round it, approximately 100. And that should make sense to you because then you notice that it's negative 96 and negative 25.88. Now let's use vectors to determine weight. A force of 600 pounds is required to pull a boat and trailer up a ramp inclined at 15 degrees from the horizontal. We're going to find the combined weight of the boat and trailer. So let's label some things. So we have BA, is the force of gravity. So here's B, here is A, so it's going straight down. That's the force of gravity. That's the combined weight of the boat and trailer. That's what we're trying to find. Then we have BC. BC here. Here is BC, and that is the force against the ramp. And then we have AC, this direction here, AC. That's the force required to pull it up the ramp. The force required to move the boat up the ramp. Okay, and we know that the force required to pull a boat up the ramp is 600 pounds. Okay, so another thing that we know is that the force required to move the boat up the ramp, that is AC, and that is parallel to the actual ramp right here. So we know that AC, the vector AC, is parallel to the ramp. And then, so they helped us out by telling us that this angle is 15 degrees here. So what can we write? Well, we know this is, so this is 15 degrees. We want to know BA. So BA, we want to know this purple here. What is this? And so we can use opposite, which we know is 600, right? We know this is 600, opposite over the hypotenuse. So we can use sine of 15 degrees is, let's write AC over BA. So then let's, we need to solve for BA, so we'll put BA over here. That's what we're solving for. Then we have AC on top still, and the sine of 15 degrees. AC, we do know that is 600 pounds, so let me go ahead and change that real quick. That is our 600 pounds. And so we can solve. So if you plug it in your calculator, you would get approximately 2,318 pounds. So try this one. A force of 500 pounds is required to pull a boat and trailer up a ramp inclined at 12 degrees from the horizontal. Find the combined weight of the boat and trailer. So it's very similar to this problem here. So see if you can solve that one. So try this out, the same exact problem, just with a couple of different numbers here. And so sine of 12 degrees equals 500 pounds over the combined weight of the boat and the trailer. And then so we're going to switch those spots. And so we find that we have approximately 2,405 pounds is the combined weight of the boat and trailer.